Hello everyone. Welcome to part 8 of my line-following robot making series. In the previous episode, I showed how to calibrate sensor data for different track and save calibrated data in EEPROM permanently. So, in this video, I will show how to handle inverse line, normally known as white line on black surface. If you're new here, make sure to subscribe to my channel and turn on the notification bell so you don't miss my upcoming videos. For this series, I'm using my custom-designed PCB carrier board made specifically for line-following robot. I have designed the board using easy EDA software and printed it from JLCPCB. JLCPCB provides easy, affordable, and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. To place my order, I simply uploaded the Gerber file to their website, selected the quantity and color options, and finalized the order. You can get 5 high-quality PCBs for just $2. What's more impressive is that JLCPCB provides real-time tracking of the entire production process, so you know exactly what stage your order is in. After a few days, PCBs arrived at my doorstep. The quality of the PCB was top-notch. Then I assembled the board with the required component. Then I tested the PCB and everything worked perfectly. If you're looking for a smooth, affordable, and professional PCB manufacturing experience, JLCPCB is the way to go. You can order this board directly from us, and when you purchase it, you'll receive a fully functional operating system with an OLED display, which is completely free with the carrier board. To place an order, simply visit our Instagram, WhatsApp, or Facebook page. Make sure that the folder name where all the files are stored is the same as one of the file names. Only then will the Arduino IDE load all the code tabs properly. If the file name and folder name are not the same, the Arduino IDE will not load all the tabs. Now let's move to the main coding part. First, I want to check the sensor pattern for inverse line detection. That's why I'm using the bit sensor show function, which I created in the previous part of the series. I'm calling this function inside the void loop when button 1 is pressed. After uploading the code, I opened the serial monitor and pressed button 1 to start the program. Here, you can see the sensor pattern when the robot moves toward the inverse line. I have noted this sensor pattern and will use it later for detecting the inverse line in the main code. Let's discuss the methodology. Normally, we take the digital value of 1 from the black surface and digital value of 0 from the white surface. Here you can see the sensor pattern for both the normal line and the inverse line. Now we need to design a system so that both sensor patterns, normal and inverse, appear similar to the robot. When the robot enters the inverse line, we simply have to reverse the sensor's digital values. We will consider digital value 0 for a black surface and digital value 1 for a white surface. After doing this, there will be no difference in the readings, even if the robot enters the inverse line. For simplicity, I converted the pattern into a decimal value, which is equivalent to 231. However, sometimes the robot may enter the line in a zigzag manner. For smoother detection, we also have to add some optional patterns and convert them into decimal values so that even if the robot enters in a zigzag direction, it can still detect the inverse line properly. Now let's move to the coding part. In the previous parts, I showed the robot's behavior when the bit sensor pattern is 0 and 255. Now, for inverse line detection, I am adding additional patterns. I am adding a new if condition with the decimal value of the inverse line pattern. When the robot enters the inverse line, this condition becomes true, and the indicator LED turns on. To observe the sensor pattern, I am including the bit sensor show function both inside and outside the inverse condition. Then I define a variable called inverse on, which can store two values, 0 or 1. I use 0 for normal line mode and 1 for inverse line mode. So initially, the value is 0, meaning normal mode. When the inverse line is detected, I will invert the value of inverse on so that the normal mode switches to inverse mode. I then control the LED based on the inverse on value. Then jump to the beginning of the code using the goto command. After that, we need to make a small change in the sensor's digital conversion based on the inverse on value. When converting the analog value to a digital value using the reference value, we first check the value of inverse on. If inverse on is 0, it means the robot is in normal mode, so I define digital 1 for a black surface. If inverse on is not equal to 0, it means inverse mode is active, so I define digital 0 for a black surface. Similarly, if the reference value is lower, meaning the sensor is on a white surface, then if inverse on is 0, the robot is in normal mode, and I consider digital 0 for the white surface. If inverse on is not 0, it means inverse mode is active, and I consider digital 1 for the white surface. Then I uploaded the code and opened the serial monitor to observe the system. As you can see, when the robot enters the inverse line, the LED turns on, and the sensor pattern does not change. The sensor pattern remains the same for both normal and inverse lines, so the robot cannot detect any change. This method also helps the robot automatically return from the inverse line back to the normal line. After testing, I commented out the unnecessary lines and uncommented the required ones. Then, in the loop function, I set button 1 for line calibration and button 2 for activating line follow mode. Finally, I uploaded the complete code to the Arduino. So let's see the final result. That's it for today's part of the video. If you found this video helpful, please subscribe to my channel and give it a like. Your support motivates me to create more helpful content for you.